Hi, welcome back to my operating system class. In the previous session, we discussed about memory management and we saw logical address and physical address. In multi-programming environment, we have a number of processes waiting for memory allocation. How this memory is allocated to these processes? Memory is also a resource. So a process should request for a memory. If it is available, it will be allocated, otherwise it should wait in the queue. So this memory can be allocated in two ways. So one we call it as contiguous allocation. So the other one is non-contiguous allocation. First, let us discuss contiguous allocation. What do you mean by contiguous? Contiguous means continuous. So ಈಗ ನಿಮಗೊಂದು process ಇದೆ. So it is of 300 KB memory ಬೇಕಂತ ಇಟ್ಕೊಳ್ಳಿ. So ಆ 300 KB ನ ನೀವು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಅಲೋಕೇಟ್ ಮಾಡಬೇಕು. ದಟ್ ಇಸ್ ಫ್ರಮ್ 2000 ಟು 2300 ಅಂತ ಅಲೋಕೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಈಗ ನೀವು ಅಲೋಕೇಟ್ ಮಾಡೋಕ್ಕಾಗಿಲ್ಲ, ಅಷ್ಟು 300 KB ಮೆಮರಿ ಇಲ್ಲ ಅಂದರೆ ನೀವು ವೇಟ್ ಮಾಡಬೇಕು. ಯಾವಾಗ ನಿಮಗೆ ಒಟ್ಟಿಗೆ 300 KB ಮೆಮರಿ ಸಿಕ್ಕುತ್ತೋ ಆವಾಗ ಅದನ್ನು ಅಲಾಟ್ ಮಾಡಬೇಕು. ಸೊ ಇದನ್ನೇ ನಾವು contiguous allocation ಅಂತ ಹೇಳ್ತೀವಿ. This contiguous allocation can also be implemented in two ways: single partition and multiple partition. So let us discuss single partition first. So usually operating system will be loaded either in the lower memory or in higher memory. So let us imagine we load operating system in the lower memory. It means from 0. The remaining memory available is given as user memory. In this example, if you consider the user is given with 1500 KB. KB, MB alla just for reference, okay? So don't stick on ishte memory ide yaake use ಮಾಡಬೇಕು ಆ ಥರ ಎಲ್ಲ ಯೋಚನೆ ಮಾಡಬೇಡಿ. So just 1500 MB or KB is available for user. Like that, if you imagine how to allocate a memory, let us see. We have a list of processes. P1 which requires 300 KB, P2 requires 400 KB, P3 requires 650 KB and P4 requires 250 KB. And this is the memory available. This we call it as a whole, H-O-L-E, whole. Now, first process is P1. P1 needs 300 KB. So we can allocate 300 KB for P1. So it will become out of 1500, if you allocate, the remaining will be 1200. Then 1200 is available. P2 requires 400 KB. So we can allocate once again for P2. So the remaining will be allocated for P3. Now how much is remaining? It is 150 KB. So 3 P1, P2, P3 we have allocated in the next memory locations. That is in continuous memory locations. The remaining is 150 KB. But P4 requires 250 KB. So the whole size is 150 KB. Can we allocate? No. So the memory is not available. So P4 has to wait. Now imagine that P2 completes the execution. If P2 leaves the memory, the 400 KB will be shown as a free memory. That is what we call it as whole. So 400 KB can be allocated to P4. So P4 will occupy 250 KB and which will be left with one more whole, that is 150 KB. So now we have two small free memory holes, that is 150 KB, 150 KB each. Now imagine we are getting one more process, P5, which is of size 200 KB. So the total memory available is 150 plus 150, 300 KB. P5 requires 200 KB. Can we allocate? We are using continuous memory allocation. That is 200 KB should be allocated in continuous memory location. But it is not available continuously. So P5 cannot be allocated in the memory at that particular moment. So P5 has to wait. So the reason is when you allocate and deallocate, we call this one as dynamic allocation. During the execution, the process is loaded into the memory and it is And deallocated means it will be left with some holes here and there. So even though the holes are available, it is not continuous. So this cannot be allocated for next processes. So this situation we call it as fragmentation, or we can also say external fragmentation. That is, this allocation, in dynamic allocation process, the memory will be allocated and deallocated, which leaves the memory with small memory segments scattered here and there. So even though the memory is available, it cannot be allocated for the other processes since it is not continuous. This we call it as external fragmentation. How to overcome the situation? We call it as compaction. So what is compaction? Moving all the used memory and unused memory to one end of the memory, we call it as compaction. So this single partition allocation will leave the memory with fragments. We can overcome this particular situation by using compaction. As I said, this is dynamic allocation. So we are going to get the fragments or holes here and there. So if a process requests for a memory and you have more than one available hole, how to allocate the memory? So for this, we have some three patterns. We call it as first fit, best fit and worst fit. What is first fit? You just look from the top to bottom. ಮೇಲಿಂದ ಕೆಳಗೆ ನೋಡುವಾಗ ಯಾವ ಪರ್ಟಿಕ್ಯುಲರ್ ಹೋಲ್ ಅಲ್ಲಿ ನಮ್ಮ ಮೆಮರಿನ ಈ ಕರೆಕ್ಟ್ ಆಗಿ ಲೋಡ್ ಮಾಡಬಹುದು, ನಾವು ಅದನ್ನೇ ಅಲೋಕೇಟ್ ಮಾಡ್ತೀವಿ, ಕೆಳಗಡೆ ಹೋಗಿ ನೋಡೋದೇ ಇಲ್ಲ. ಸೊ ಇನ್ ದಿಸ್ ಎಕ್ಸಾಂಪಲ್, ಚೆಕ್ P1 is occupying 300 kb and P2 is occupying 400 kb. Now P3 is in need of 350 kb memory. So the whole 1 contains 500 kb and whole 2 contains 400 kb. So now we are going to search from the top. Yes, 500 kb is sufficient for P3. Yes, then we allocate P3 with this whole 1. This is first fit. The second one is best fit. Best fit means we are in need of 350 kb memory. We are provided with two holes, 500 kb and 400 kb. ಈ ಎರಡು ಹೋಲ್ಸ್ ಅಲ್ಲಿ ಯಾವ ಮೆಮರಿಯಲ್ಲಿ ನಾವು ಈ 350 kb ಪ್ರೋಸೆಸ್ ನ ಅಲೋಕೇಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಫ್ರಾಗ್ಮೆಂಟ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಅಂತ ನೋಡಬೇಕು. ಸೊ 500 kb ಗೆ ಅಲೋಕೇಟ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಉಳಿಯುತ್ತೆ? 150 kb ವೇಸ್ಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ 400 kb ಇದೆ ಅಲ್ಲ, ಹೋಲ್ 2, ಇದನ್ನಲ್ಲಿ ಅಲೋಟ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬ್ಯಾಲೆನ್ಸ್ ಇರುತ್ತೆ? just 50 kb. So if the fragment is very small, so that is the best whole, or that is the best fit for the process. So in best fit, we will search the entire list of whole and we will allocate the process with the whole which matches close to our memory requirement. That is best fit. The third method is worst fit. So now we ನೋಡಿದ್ವಿ 50 kb ಉಳಿದ್ರೆ most of the processes will be larger than that 50 kb. So if the fragment size is little bit big, then it can be utilized by other process. So we are trying to find a hole which is very large so that the fragment size also will be large, so that it can be allocated to the other process. So ಇಲ್ಲಿ ನೋಡಿ 500 kb 400 kb ಇದೆ. ಈ ಎರಡಲ್ಲಿ ಯಾವುದು ದೊಡ್ಡದು? 500 kb. So we will allocate P3 to 500 kb if it is a worst fit. So the balance will be 150 kb. ಈಗ P4, if it is need of 150 kb, you can allocate it for P4. So these are the three ways of allocation of available memory in dynamic allocation. So this will come under single partition method. So single partition method will leave the memory with external fragments, and you can overcome this particular issue by compaction. Next comes the multiple partition. Multiple partition, we are not going to imagine the entire user memory as one single whole. We are going to divide the memory into partitions, that is 1, 2, 3 in this example 500 KB each. So andre ಯಾರು ಎಷ್ಟು ಕೇಳಿದ್ರು 500 KB ಕೊಟ್ಬಿಡ್ತೀವಿ. ಈಗ ನಿಮ್ಮಲ್ಲಿ ಬಂದು ಯಾರೋ ಒಬ್ರು ಒಂದು ಪೇಪರ್ ಬೇಕಂತ ಕೇಳ್ತಾರೆ, ಒಂದೇ ಲೈನ್ ಬರಿಬೇಕು, ಒಂದು ಫೋನ್ ನಂಬರ್ ಮಾತ್ರ ಬರಿಬೇಕು. ನಾವು ಏನು ಚಿಕ್ಕದು ಪೇಪರ್ ಕೊಡೋಕ್ಕಾಗತ್ತಾ? ಇಲ್ಲ. ಶಾಪಲ್ಲಿ ಹೋಗಿ ಕೇಳಿದ್ರೆ ಒಂದು ಫುಲ್ ಶೀಟೇ ಕೊಡ್ತಾರಲ್ಲ, ಅದೇ ಥರ ಯಾರು ಕೇಳಿದ್ರು ಫುಲ್ 500 KB ಕೊಟ್ಬಿಡ್ತೀವಿ. So that is what we call it as multiple partition. We divide the entire memory, user memory into partitions of some fixed size. The entire user memory is divided into multiple partitions and every process will be allocated with one partition each. So P1, if it is in need of 300 KB, we will allocate the 500 KB partition. So the remaining 200 KB will be left free, but it cannot be allocated for any other process. P2 is in need of 400 KB. You can allocate partition 2 and it will be left with 100 KB. Ignore P3 is in need of 650 KB, but nam partition size eshtiде 500 KB. Allocate madakagatta? Illa. So our process may require different sizes. If the partition size is fixed, you cannot allocate for large processes. This is one issue with multiple partition. And the other issue is if the process occupies only part of the partition, that is out of 500 KB, only 400 KB is occupied. The remaining memory will be left unused. Compaction madakagalla alva. So that we call it as internal fragmentation. We call it as internal fragmentation because the memory is completely allocated to a process and it cannot be used by any other process. In multiple partition algorithm, we have internal fragmentation. Also, if the process size is larger than the partition size, it is difficult to allocate it to a process. Have a nice day.